Assalamu alaikum. Let's go for the question 11. Curve has parametric equation x is equal cosine t, y is equal half sine 2t, and t has to be between 0 and 2 pi. We first have to find the expression for dy over dx. Then we have to find the equation of the tangent to the curve when t is equal pi over 6. Then the lines L1 and L2 are further distinct tangent to a curve. Given that L1 and L2 are both parallel to a tangent to a curve point A, find the equation of L1. So practically L1 and L2 are some other tangents to the same curve, and they are both parallel to tangent that we have to find out, and we have to find later these two lines. So let's start with A. So dy over dx will be dy over dt over dx over dt. So when we differentiate it, it will be half times cosine 2t times 2 over minus sine t. So this will be equal to the cosine 2t minus sine t. I don't see any other smart way to simplify it, so I'm not going even to try it. So b will be, we have to find the tangent when t is equal pi over 6. So in that case, cosine of pi over 6 is cosine of 30. Cosine of 30 is square root 3 over 2. And this has to be half of sine of 60. Y will be equal square root 3 over 4. What will be our gradient? Our gradient will be equal to cosine of 60 will be 1 over 2. Sine of 30 will be 1 over 2. We copied minus, it will be negative 1. So now actually our tangent will be y minus square root 3 over 4 is equal minus x plus square root 3 over 2. When I multiply everything with 4, I will have 4x plus 4y, 4x plus 4y. This will go on the other side, minus 2 square root 3. It will be minus 3 square root 3 is equal to 0. So let's now find other two lines. They should have same gradient. So we have to find other two values of t that have that gradient. So cosine 2t over minus sine t is equal negative 1. This will be cosine square t minus sine square t, or when I add the plus and minus 1, it will be plus 1 minus cosine square t minus sine square t. It will be 1 minus 2 sine square t over sine t is equal negative 1. When I multiply this with the sine, I will put this here. So I will have 1 minus 2 sine square t over sine t minus 1 is equal to 0. So it will be sine t 1 minus 2 sine square t minus sine t is equal to 0. This fraction will be equal to 0 when numerator is equal to 0. I will just put sine t is equal a. I will have 1 minus 2a squared minus a is equal to 0, or when I multiply with negative 1, 2a plus a minus 1 is equal to 0. I can factorize it as 2a minus 1, a plus 1 is equal to 0. So now a can be minus half and a can be minus 1. This is very important because a shouldn't be 0. If you got a 0, you should have to cancel this. So first value, we will have that sine of t is equal minus half. This equation, sine is negative in this and this, so tangent can be minus, no, because it is from 0 to 2 pi, so it will be 30 plus 180, it will be 7 pi over 6. Here pi will be equal, here pi would be equal 11 pi over 6. So, I did mistake. This is going on other side is positive. So sine t is equal to half. It will be, t will be pi over 6 or 5 pi over 6 in positive in first and second quadrant. And a is negative 1 when t is negative 1 will be only here. So it will be minus 3 pi over 2. So these two lines will be touching curves in this and this point. But because this is already here, so we have to check only for these 2 points. So now, if we choose this, I'm going it here, I hope you see. Can you see? No. Okay, choosing here, I will go for next page. Now I will be able to see. If t is equal 5 pi over 6, then x is cosine t, y is half sine 2t. I have to substitute cosine of this will be minus half cosine of 5, it is same like cosine of 30. It will be cosine of 30, it will be minus square root 3 over 2, and sine will be equal minus square root 3 over 4. So our equation will be minus square root 3 over 4 is equal negative x minus square root 3 over 2. And when I sort it out, y will be equal minus x minus 3 square root 3 over 4. What about when t is equal minus 3p over 2? In this case x will be 0, y will be 0, so it will be simply equation y is equal minus x. So this is the finish of the example of the 11C.